So what is a polynomial? It's just a special kind of expression. And it's an expression where there are only very specific operations that you can perform on the variable itself. So you can use the four basic operations: addition, subtraction, multiplication, division. So what that means is you can take your variable, like x, and you can add 2 to it if you want. You could subtract something from it if you wanted to. You could take x and you could multiply it times anything in the universe you want, times anything. And you can take x and you can divide by a number. All of these would be polynomials. So the things that are not allowed, what disqualifies you from being a polynomial, is if you have a variable in the denominator. So no variables in the denominator. You can't divide by x. And I know you might be thinking, but you just said we could divide. No, no, no. You can take an x and you can divide it by anything. You can't do it the opposite. You can't divide by the number x and be a polynomial. You also can't have absolute value. So we're going to write no absolute value. No absolute value. So you could have x plus some number like 2, but the second you put absolute value around it, it is no longer a polynomial. And the final thing is there are no roots. No square roots, no cube roots, no nothing. No funny x raised to a funny fraction. That would mean this little fraction. We won't see this. This is more of an algebra 2 problem. Those would also disqualify you. So I want you to hit pause, and I want you to look at these 9 different expressions and decide which are polynomials and which aren't. And if they aren't, circle the part that's a problem. If you guessed the 3 in the middle, you are correct. You can't have a square root of x, you can't divide by x, you can't have absolute value. It breaks all 3 of those rules. But I hope that you weren't tricked into this. This one here is totally okay. Because again, you are taking x and you are dividing by something. You are allowed to do that operation. This is also okay because you took x and you multiplied it times a number. Granted, square root of 2 is a gross number, but you're still allowed to do that. You aren't allowed to take the square root of x, but you are allowed to multiply x times anything you want. And the last one is perfectly fine. So we're going to go and check out, well, what are the different types of polynomials? The word polynomial just means many terms. And just so you know, terms are separated by addition or subtraction. Multiplying things together does not make them different terms. So you'll see what I mean here. A monomial, which is kind of a contradiction in terms, means one term. And an example of that would be like 6x squared. That's one thing. Nothing is being added or subtracted to it. Even something like 20xy, that's still only one term. So that would count as a monomial. A binomial, as you can imagine, just like a bicycle has 2 wheels, is 2 terms. And so an example of that would be like x plus 6. X is one term, 6 is the other. You could have 6x squared minus 20xy. And this is still a binomial because you have one term there and your other term there. We can all see where this is going. A trinomial is 3 terms. And most of the quadratics we see are trinomials. X squared plus 7x plus 10 would be a great example of a trinomial. And finally, a polynomial is just many terms. Once you've gone beyond 3 terms, we just call it a polynomial. So we need to be able to identify polynomials, and we need to be able to tell what different types they are. So let's go and check how you can tell which degree we have. That is super important. We're going to start with just single variables because that's pretty much all we're going to see in Algebra 1. So a single variable, the degree is determined by the highest exponent is the degree. We'll worry about multivariable ones a little later. So an example, the degree of 0 is just something called a constant. It's going to appear as just a number because x to the 0 equals 1. So if I have an example would be 27, that would be a 0 degree. 32, that would be another 0 degree because technically behind that 27 or behind that 32 is an x to the 0. Since x to the 0 is 1, we don't actually write it. The second one, when it's a degree of 1, when you have an x to the 1, this is called a linear function, all right? It's linear, and it's because if you graphed it, it would just be a line. So examples would be like 3x plus 5. You have a y-intercept of 5 and a slope of 3. Another thing that would be linear would just be 6x. Now, a degree of 2, a second degree is called a quadratic. And we do want to know that word because they throw it around all the time. A quadratic is any type of x squared. So an example would be 6x squared. Or another example would be x squared minus 3x plus 10. And x to the third is called a cubic. You could just say third degree, and I would go with that. But a cubic is something like 5x cubed, or just a plain old boring x cubed. X to the fourth is called a quartic. I would say the three that are super important are the 0 degree, first degree, second degree, and even a third degree. But beyond that, we would probably call this just a fourth degree polynomial, but its real name is a quartic. And that would be an example like 3x to the fourth minus 2x cubed plus 5x squared minus 10. That would be a quartic because the highest degree, the highest exponent is a 4. And lastly, the fifth one is called a quintic. Again, we're really not using these words. I would personally just call it a fifth degree, but I do want you to know it has a name. And again, it's anything to the fifth power. So like 9x to the fifth minus 13x squared. Since the highest exponent is 5, it is a fifth degree polynomial. Now, we're not going to worry about the multivariable right now, but I do want you to try this. Let's try 2 of them together, and you're going to do the other 2. We first want to say, what is the degree? So in this case, the highest exponent is that x squared. So this is a second degree, or a quadratic. And when they say to write it in descending order, what this means is you take your highest exponent and you start to go down from the highest to the lowest. So the highest exponent is a negative x squared. The next exponent would be x to the 1, which would be right here. So we're going to say plus 7x. And then lastly, I'm going to write my constant, plus 14. This crazy thing is a lot bigger and more involved. So the highest one is x to the 7th. So this, if I had to say what it was, it is a 7th degree. Now I need to put it in order. The highest exponent is the 7th, so we're going to start with negative x to the 7th. Then we look for who's the next highest exponent. That would be this. So I'm going to write that whole term, plus x to the 5th. Next, we're going to go with an x squared. So I'm going to go there next, plus x squared. Then I try this. There's just the single x, plus 13x. And the last thing I write is my constant, the one that doesn't have an x attached to it. It has a secret x to the 0. And that's it in descending order. So why don't you try the next two? And I'll check those in class. And we will talk about these in class. If you want to know for the bonus on the quiz, let's try this out. When you have mixed variables, you add the total exponents. So what I have here with the y to the 5th and x to the 1, this would be a 6th degree. So in case you want to write it down before next class, if you have a multivariable, add the exponents from the term with the greatest amount. So if you had xy squared minus x to the 5th y to the 3rd, this guy wins. And we would take it and we would add up the total amount. We have x to the 5th, y to the 3rd. We have a total of 8. So this would be an 8th degree. See you in class.